Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Najib Muhammad Salam. My meeting number is AA221365. Alright, I'm the presenter for my group. It's group 1, and we're focusing on the dynamic group project. Alright, let's begin with the motion of projectile and its rectangular component. Alright, motion of projectile rectangular component. To introduce the concept, let's define a projectile as any object that is cast, fired, launched, or thrown. It follows a trajectory, which is the path it takes. Some examples of projectile include a ball being pitched or a bullet being fired from a gun. Gravity plays a significant role in projectile motion, being the most influential force. However, other forces may have a negligible impact. Okay. Derivation. Path of projectile. Now let's derive the equation for the path of a projectile. We consider a particle projected with an initial velocity u at an angle a to the horizon. By splitting the initial velocity into its horizontal and vertical component, we can derive a parametric equation for the projectile trajectory. The result equation, which is a parabola, represents the path of the projectile. Right, moving on to nature of trajectory. We find that the path of the projectile is a parabola by analyzing the equation of motion and principles of projectile motion. We can determine the range, maximum height, time of flight, and other relevant characteristics of the trajectory. Now, let's explore the application of projectile motion in golf and football. By understanding the principle of projectile motion, we can analyze and solve real-world problems related to this sport. For example, we can determine the initial speed required for a quarterback to throw a football and reach a receiver accurately. Alright, let's shift our focus to curvilinear motion, normal and tangential components. In curvilinear motion, we have the normal component, which act perpendicular to the curve, and the tangential component, which act parallel to the curve. These components help us understand various motion in curve shape such as arc and oval. Okay, as an example, they consider a boat moving along a circular path. We can analyze its motion using the normal and tangential components. This understanding is fundamental to comprehending how boats navigate curve in the sea and lake. Okay. Moving on, let's discuss the relation between force, mass, and acceleration. According to Newton's second law, force is equal to mass times acceleration. This relation is vital in engineering applications such as elevator system. By understanding this concept, we can design safe and efficient elevator system by determining the force requirements, carrying capacity, and proper acceleration. Okay, let's now delve into the principle of work and energy. Work is defined as a transfer of energy into an object due to displacement. Energy, on the other hand, is the ability to do work. By analyzing work, energy, and power, we can optimize system efficiency in engineering application like hydraulic system. Lastly, let's explore the principle of linear impulse and momentum. Momentum is a measurement of mass in motion given by the product of mass and velocity. Impulse quantified by force acting over time is closely related to change in momentum. Understanding this principle help us comprehend the motion resulting from forces acting on objects. For the conclusion, the topic covered today, motion of projectile, curvilinear motion, force, mass and acceleration, principle of work and energy, and principle of linear impulse and momentum are all crucial in engineering application. By demonstrating digital scale and utilizing appropriate tools and resources, we can analyze and solve complex problems efficiently and effectively. That's all for me and for my group. Thank you.